Nomenclature is the fancy word we use to describe naming or the naming of organic compounds, and it says here the IUPAC, or the International Union of Pure and Applied Chemistry, is responsible for chemical names. So again, this is an international group of scientists that get together at conferences and the like, and they come up with rules that can be applied over the entire planet for naming organic compounds, so that there's consistency in the scientific community in terms of naming organic compounds. And we call this nomenclature. And before learning the IUPAC rules for naming alkanes, the names and structures of the 8 alkyl groups must be learned. So these are things like methyl, ethyl, propyl, butyl, isobutyl, tertbutyl, so on and so forth that we looked at in a prior video. These alkyl groups are historical names accepted by the IUPAC and integrated into modern nomenclature. And that's why you have to know all the alkyl groups that we've already taken a look at. Now, of course, one of the first things you have to do in organic chemistry is memorize the first 10 straight chain alkanes: methane, ethane, propane, butane, pentane, so on and so forth. And so it's important that you understand the prefixes meth, eth, prop, but, pent, hex, hept, oct, non, and dec. They represent a specific number of carbons. And so if you see the prefix hex, for example, you have to know that that represents the number 6, so 6 carbons. And so it's important that you have this table down pat. Now for the IUPAC rules, we'll start with rule number 1. It says the base or the parent name for an alkane is determined by the longest chain of carbon atoms in the formula. So it's important that you identify the longest chain of carbon atoms. Now the longest chain may not always just be laid out for you horizontally on the page. It may bend, it may twist. It is seldom horizontal. Any carbon groups not part of the base chain are called branches or substituents, and those are things like methyl, ethyl groups, propyl groups, isopropyl groups, so on and so forth. And these carbon groups, again, we call those alkyl groups. Let's take a look at rule 1 being applied. It says find the longest carbon chain in each of these molecules. Now, if I was to just take this chain here in this molecule, if I was to take this, I would see that I have 1, 2, 3, 4, 5, 6 carbons. But it tells me here that the actual longest chain in the molecule has 8 carbons. So there must be something wrong here. Now, let's take a look at a different chain. What if I follow this chain here like this and then go up here? You can see that this chain does in fact have 1, 2, 3, 4, 5, 6, 7, 8 carbons. And then you can see that on carbon number 4, I have this CH3CH2, which is an ethyl group. And on carbon number 6, I have this CH3, which is a methyl group. If you look at the second example, it says that the longest chain has 7 carbons. This one's a little bit easier to identify, and you can see that it goes like this is the longest chain. And so you can see that we have something on the 3rd carbon here. And that something on carbon 3 is a methyl group. Rule number 2 says that we number the carbon atoms in the chain starting from the end with the first branch. If both branches are equally distanced from the ends, we continue until a point of difference occurs. So if you take a look at the first molecule that we looked at on the last slide, you can see that they start numbering up here. And the reason why is because our first substituent lands on carbon number 3. If you had numbered in the opposite direction, starting here saying that this carbon is 1, 2, 3, 4, then the first substituent, the ethyl group here, would land on carbon 4. This numbering system would be incorrect because we want to number the carbon atoms in the chain starting from the end with the first branch, the branch at the lowest possible number. The same thing applies to this example here, that of course we only have one substituent. which is this methyl group. And if we number starting over here, it is on the third carbon. If I had gone in this direction, 1, 2, 3, 4, 5, the methyl group would be on carbon number 5. Again, we want to give it the lowest possible number. Then we write each of the branches or substituents, so our ethyl, our methyl, so on and so forth. We write those branches or substituents, our alkyl groups, in alphabetical order before the base name, and that's the longest chain. So if we have a halogen in our molecule, like fluorine, chlorine, bromine, or iodine, those usually come first. And if I have a fluorine, my fluorine, I give that the name fluoro. If I have a chlorine, I call that a chloro. If I have a bromine, I call it a bromo, and an iodine, I call that an iodo. Then we indicate the position of the branch on the main chain by prefixing its name with the carbon number to which it's attached. So let's say, for example, you have a methyl on the third carbon, you would say 3-methyl. These last two rules are very important. You separate numbers and letters with a hyphen, so a hyphen is just a dash like this, and we separate two or more numbers with a comma. So you have to know when to use a hyphen and when to use a comma. Letters are not separated by hyphens or commas. Let's take a look at an example here, and you can see the longest carbon chain has 6 carbons in it, and I'm going to start numbering like this: 1, 2, 3, 4, 5, 6. So my parent or my base is a 6-carbon alkane, so it's some kind of hexane. What else? I have a methyl group at carbon 2, so I would call this a 2-methyl because I separate numbers and letters with a hyphen. And then I have an ethyl group over here, so I would call this a 4-ethyl. Now I'm going to list my substituents, my 2 alkyl groups, in alphabetical order before the base or the parent name. Now, since E comes before M in the alphabet, I'm going to call this compound 4-ethyl 2-methylhexane. Now you may be asking, why don't we number from this end? 1, 2, 3, 4, 5, 6, like this. The reason why this is incorrect, because our ethyl group would have the number 3 and our methyl group would have the number 5. Remember, we go for the first point of difference and we want to give our alkyl group the lowest possible number. So a 2-methyl is lower than a 3-ethyl, and therefore this numbering system would be incorrect. This next rule is kind of an interesting one. It says hyphenated and number prefixes are not considered when alphabetizing groups. So if we want to name the compound below, we have to consider this rule. And what it's telling us is that if you have a prefix like mono, di, or tri, which we will look at later on, or if you have sec or tert, we ignore those prefixes. The only prefixes that we do not ignore are iso, cyclo, and neo. So what that would mean, if you have isopropyl, you would alphabetize it according to the letter I. If you had cyclopropane, you would alphabetize it according to the letter C. And if you had neopentane, let's say, you would alphabetize that according to the letter N. But if you had, let's say, sec-butyl, since the prefix sec is not iso, cyclo, or neo, you would alphabetize according to the letter B. If you had tert-butyl, again, the same thing would apply. Since tert is not iso, cyclo, or neo, you would alphabetize according to the letter B. So with that in mind, let's take a look at this problem. Now I've gone ahead and done some of the work already, and I've identified the longest chain as such. And the longest chain has 9 carbons in it. And I have 2 alkyl groups on this parent chain. Here they are. I'm going to number starting here, 1, 2, 3, 4. because this means my first substituent is at carbon 4. If I'd started on this end, I would have 1, 2, 3, 4, 5. 4 is lower than 5. Therefore, my numbering is correct. 5, 6, 7, 8, 9. So my parent or my base is nonane. And what are these alkyl groups? Well, hopefully you have them down a little bit by now. And the one that's at carbon 4 is a 4-isopropyl. A 4-isopropyl. And the one at carbon 5 is a 5-sec-butyl. Now the question becomes, how are we going to put all of this together? Well, nonane is my base or my parent, so that's going to come last. And if I look at my two substituents, isopropyl, since we have the prefix iso, we're going to alphabetize according to the letter I. And for the sec-butyl, since sec is not iso, cyclo, or neo, I'm going to alphabetize according to the letter B. So B comes before I in the alphabet, so this compound must be 5-sec-butyl, 4-isopropyl, nonane. The last rule we have to look at says that when a branch or a substituent occurs more than once, we prefix the name with di, tri, tetra. After tetra, there are more prefixes. Di means 2, tri means 3 times, tetra is 4 times. We won't look at anything past 4 times. But for example, if I have 2 methyl groups in a compound, I put dimethyl. If I had 3 ethyl groups, for example, I would put triethyl. So what it says here is to list the number of the carbon branch for that substituent to the name with a separate number for each occurrence, and we separate the numbers with commas. Let's take a look at an example. I spent some time looking at this molecule, and I determined that the longest carbon chain is this one right here. So my parent is going to be heptane, because the longest carbon chain that I have highlighted in yellow has 7 carbons. Now I'm going to number those carbons starting from the left, because that gives my first substituent the number 2. If I had started from this end, I'd have 1, 2, 3, and then this ethyl group would have the number 3. Since 2 is a smaller number than 3, my numbering is correct. So 1, 2, 3, 4, 5, 6, 7. So the base or the parent of this compound, since it has 7 carbons, the longest chain, must be a heptane. Well, let's identify the substituents. I have a methyl group at carbons 2 and carbon 3. And the way that I apply the previous rule is that this is a dimethyl, and I provide a number for each one of those methyl group locations. So I have 2,3-dimethyl. And then I also have a 5-ethyl. Now in terms of alphabetization, remember we ignore all prefixes except iso, cyclo, and neo. And since the only prefix we have here is di, and di is not iso, cyclo, or neo, the dimethyl will be alphabetized according to the letter M, and the ethyl will of course be alphabetized according to the letter E. Since E comes before M in the alphabet, this compound must be 5-ethyl, 2,3-dimethylheptane. Let's get some more practice. This question says to identify the IUPAC name for this compound. I've already gone ahead and highlighted even the alkyl groups, and you can see that the correct numbering would go this way: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the base or the parent has 10 carbons, so this must be a decane. And now we take a look at the substituents. You can see that on carbon 3 we have 2 methyl groups, so this must be a 3,3-dimethyl, which we would alphabetize according to the letter M. At carbon number 6, we have a 6-isobutyl, because the one that's in red here, this is an isobutyl group. So we'll write that down. We have 6-isobutyl, and you'll remember The iso is alphabetized according to the letter I. And then also on carbon 6, we also have a 6 ethyl group. Now when I put all this together, I have the letters I, E, and M. And E comes first, I comes second, and M comes last. So this molecule must be 6 ethyl, 6 isobutyl, 3,3-dimethyl decane.